Hey guys, welcome back. Good morning, everyone. As you can see, I attempted to record this once already, but let's try this again. So today we're going to be doing chapter 4.1 carbohydrate classification. So carbohydrates, they're going to be hydroxide, aldehydes or ketones. Monosaccharide is one single sugar, like here. So this would be a monosaccharide, one glucose sugar. So the way that we count them is three carbon trios, tetros, pentos, hexos, right? And that should be very simple for all of us because we should all already know our prefixes. So your functional group is either going to be an aldose or a ketose, and what I mean by that is your functional group is either going to be an aldehyde here or a ketone here. Okay, aldose, ketose, and let me erase this. So the main difference between the two is your aldose is always going to be at the end of your chain, and your ketose is always going to be on carbon 2. 1, 2, 3, 4, 5, 6. Yep. Ketose is always going to be on carbon 2. Okay? So that's name classification. Next, nomenclature. Again, like we just talked about, aldehyde, aldose, ketose, ketone. Next, we're going to go on DNO. So we're talking about the highest numbered chiral carbon. So the highest numbered chiral carbon is always going to be this one, carbon 5, obviously, because 1, 2, 3, 4, 5. And what tells it if it's D or L is dependent on where the OH on carbon 5 is. So all of these are D sugars because as we see the OH is all on the right. Now ribose is only 5 carbons, so the highest form for ribose is going to be 4. Right, 1, 2, 3, 4. So now we're gonna see that this is also on the right. Okay, so what we usually say, what my tutor told me, is uplifting. So like uplifting as in the left. Okay, so wait, sorry, that gets into something else. So when we're gonna, sorry, I got there too quickly, but we're gonna see that here. So we'll keep going for now. Just know when you draw your structure, if your carbon is on the right, it's down, and if your carbon's on the left, it's up. Okay, but we'll get into that later. But yeah, uplifting, that's going to be helpful for later. So next we're going to talk about the stereochemistry. So carbohydrates have multiple chiral centers, right? And if you watched my previous videos, you should know what a chiral center is. So enantiomers are D versus L. So your L sugar is enantiomer of your D sugar, and your D sugar is your enantiomer of your L sugar. So diastereomers, they're not mirror images, and then they're different at one or more chiral centers. Now, this is where we usually get stuck, right? Epimers versus diastereomers. This was something I was confused about when I took Biochem 463, but it's relatively simple. So now, if we look at glucose and galactose, right? Let's erase all of this. If you look at glucose and galactose, I'll give you guys a second. What is difference about it? Okay, so do you see how glucose, so if we look at the carbons, right, carbon 2 is the same, carbon 3 is the same, but do you see how carbon 4 is different? Okay, you see how the OH is flipped, and then obviously carbon 5 is the same. So all these other carbons are the same except for carbon 4. So we're going to say galactose is a C for epimer of glucose, or glucose is a C for epimer of galactose. Okay? So in epimer, we're talking about one single carbon, right? And, people always ask, by people, I mean me, I asked this to my biochem teacher, okay, what's the difference between a diastereomer and an epimer? Well, an epimer is just a subset of diastereomers, okay? And then your anomers are going to be, they're going to be at the anomeric carbon, which we're actually going to get more into the next one. But the anomeric carbon is just one carbon away, okay? So one carbon away from the O group here. It's going to be your anomeric carbon. So if we see here, see how this is down and that's up. So these are anomers, right? Beta, alpha, again, down and up. Okay, so we're definitely, and again, here's some wording on it if you need it. So OH if it's trans, and then if it's cis, okay? And we'll get more into that as we keep going. So if you just came from chapter 4.1, I low-key just like, I don't know why I started it, but I just got lost in the notes. But let's actually get started on cyclic sugar molecules. So as far as hemiacetal has hemiketal formation, I actually already have a video on the mechanism. So we're not going to be talking about the mechanism today. But what we will be talking about is when we have, it's actually, these might be actually helpful. So when we have these guys, okay, your cyclic sugar, I mean your Fisher projection sugar molecules, they can like form, right? They can become cyclic, and then you can connect your carbon there. So when that happens, you can make two different type of rings. Okay, 6-membered ring is a pyranose, and then 5-membered ring is a furanose. So the carbon that was on the carbonyl becomes the anomeric carbon. Okay, and again, the anomeric carbon is going to be the carbon that is one away. Okay, so B when you have a beta and alpha. Okay, so I really do like to remember, I like this way where it's trans and cis, because it really does fall back to what we know in organic chemistry. So do you see how here, if we drew it, let's say that we drew it, let me draw it without the O in the middle, right? Let's say that we drew it like this. And then we have O. Do you see how this is trans versus, let's do the same thing here. We have OH. See how it sort of looks like what we would see if we had trans and cis. Okay, so that's the way that I use to really remember this is alpha trans beta cis, and I feel like that's gonna make it nice and easy for you. So there's different conformers. You have a chair and a boat. And then this is again something from Orgo 1. Bulky groups prefer equilateral positions. I will say this is what you're probably going to see it in more. Chair is a little common as well, but we like the Hayward projection a lot more. And then maturation is going to be the interconversion between alpha and beta in aqueous solutions. Okay, so you can change from alpha to alpha, and it is going to be catalyzed by acids or bases. So it was actually a pretty short chapter. Not much to take out of it. Very straightforward. Definitely understand that these can cyclize. Then we can go ahead and then we can make these guys. And yeah. So I might actually combine this with 4.1 now. So I'll see you guys in 4.3.